In example 3, we need to graph and analyze z of x is equal to negative log base 3, and then in parentheses x plus 4. When you look at this equation, we have a base of 3. There's a negative sign out front, which means it's going to be reflected. And then this x plus 4 right here is going to be a shift left by 4. As a matter of fact, if we want to right away, we could write that our asymptote is x is equal to negative 4. And you can plot it if that helps you to graph. It's often a good idea to do that so that you don't cross that line, because we definitely don't want this graph existing over here to the left. To continue with the graphing part, we can solve this equation for x, and we're going to make z of x y. So that'll be negative log base 3 x plus 4. To solve for x, we need to first get rid of this negative sign, and we'll have log base 3 of x plus 4 is equal to negative y. Then we're going to change this into exponential form, so it's 3 to the negative y power is equal to x plus 4, and then subtracting 4, we'll finally have x by itself. This is a nice thing to do so that we can pick nice values or good values for y to investigate some representative points and plot those and hopefully connect them up, and it should look like like log base 3 just flipped or reflected. In this case, it'll be over the x-axis. So if we plot some points, remember that we've got z of x here, or y, and we need to pick some good values to work with. Maybe negative 1 will work. 3 to the negative y, which is 3 to the negative, or the opposite of negative 1, which is 3 to the first. So 3 to the first is 3. 3 minus 4 will give us negative 1. If we choose 0 here, 3 to the 0 power is 1. 1 minus 4 is negative 3. We could choose positive 1 as well. So 3 to the negative 1 is 1/3, making 1/3 minus 4, negative 3 2/3. And if we chose another one, maybe even positive 2, this would be 1/9. 3 to the negative 2 is 1/9. 1/9 minus 4 is negative 3 8/9. And we could even continue on in the other direction if we wanted to, but I think this will probably give us enough points to plot this fairly accurately. Of course, the more points that you plot, the better your graph is going to look. So we'll do negative 1 to begin with. So we've got negative 1 and negative 1. We have negative 3, 0. So negative 3, 0 is right here. We've got negative 3 2/3 and then 1. So negative 3 2/3 and 1. And then negative 3 8/9. So very, very close to negative 4. And we need to go up 2 with this one. As we connect these then, this will look just like this. And we could continue this on to the right-hand side. And this graph, you know, the normal one, like a log base 3 of x, would look something like this. And it's definitely been shifted left 4, and it's been reflected or flipped over the the x-axis. If we want to analyze this a little bit more, we've got our asymptote right here, x is equal to negative 4. We could do definitely domain and range. So if we do the domain here, the domain are all the possible values of x. In this case, we can't get exactly to negative 4 and nothing lower than negative 4. So this would be negative 4 to infinity. These are all the possible values that will exist for x. And then the range are all the possible values of y. And we can see here that as we make x really, really big, this graph does continue to go down or descend, and it will continue down to infinity, or negative infinity in that case. So negative infinity to infinity, all real numbers, will be your range.